Welcome to logi.DOC, the FBD editor for VGB R170C. In this presentation I would like to show you how to create a new project based on the AE&E Landsys standard. If you want to create a new project, you have to start the project wizard. This project wizard gives you the possibility to select from a project list a new project type like this. You can create a new project. You got a selection of existing template projects. The VGB project for AE&E is selected and you say next, and now you are asked for the project directory where you want to create a new project and what is the name of this project, and then you say next, and now you will be asked for some project settings, and these project settings could be modified later on also. Then you say finished, and now the system copies the data to the system, to the folder, and creates a complete new project. Here you see this new project, and you see we have a complete structure which is defined in our template project. You see we have a plant, we have a function group, we have our documentation types, and we can start to create a new structure and a new documentation. At first we have to rename this structure into the VGB documentation layout. So one, for example, is the plant number, and the function group for this documentation will be renamed into LCA 50. So you see now the function group is also modified in this name. So we have a structure which is called 1, and we have a sub-level which is called LCL 50. Now we start creating our logics, and we create at first some drives. Therefore we have our typicals, and these typicals, they exist and they are described in a presentation. So I select the typical, I say right mouse key, and I have to copy this typical into our project scope. Now I have to select the target where I want to have this typical. I will copy it into 1 LCL 50 YFT. Now I have to rename the name into the KKS for this documentation. You see I renamed this into 1 LCL 20 AA001 to create a valve. Then I press OK, and the system will give me some data. These data are really important because these are the placeholder. That means the signals which could be used to build up the logic page. When you go to the name column and you press right mouse key on this name column, then you see you got a possibility to find and replace the names. You see I fill out this find what as the placeholder name, and replace with, I fill out with the name of our KKS. And when you press replace all, then you see you got new names, and you can say OK to get a new logic page. This logic page is now inserted into 1 LCL 50 YFT, and you see there is the documentation. When you make a double click to this documentation, then you will see what was happened in the background. You see the output signals for this valve are directly named into the right KKS. You have the right signal text, and of course the two feedback signals are directly generated. You see it here, and additionally, this is really important, you see that these two signals are also inserted into the signal register. That means they are directly inserted, they are directly appended into the Microsoft Access database. I would like to do this procedure again to get one additional drive from another typical. Therefore I select the typical again, I start copy to, I set the name for the target documentation. Again I'm asked for the renaming of the signals. I define the renamings and I press replace all. They are replaced now, and with these replacements I can say OK, and the system generates the new logic. You see the logic is inserted. We can make a double click to take a look on it. We have one page, we have the signals, we have the feedback signals, everything is OK. Now I would like to add a sequence into this one LCL50. Therefore I go to the typicals, YFS holds all typicals for the sequence, and I can take FG-04-04 to create a sequence. Again, I make copy to, I do the renaming. Now I'm asked for the names of the steps and the names of the sequence header. And of course I do the renaming. I do replace all, and I say OK to get the logic. You see, it's already created, and the system gives me now the possibility to connect the logic of the sequence to the base level for the control logic. For this reason, I open the sequence to check the signals at first. You see, the signals are generated, we have the feedback signals, we have all signals which were necessary. When you take a look into the signal list, when you click to this SIG register, then you see all the signals are available. Let's do an example for the connection. I would like to activate in step 01, I would like to activate both the solenoid valve AA001 and the motor AP001. Therefore I have to make a connection from this step to these two devices onto the left side of the sheet. For this reason I open at first the solenoid valve. This is the solenoid valve, and now I need the signal. Therefore I can open the signal register like this, and you see I can take this signal and I can drag this signal into our sheet like this. You see, while dragging the signal into this sheet, I got a reference to the sequence, and I can make a connection to this input. And when this input is saved, then you will directly see that the system automatically builds up the cross-reference. Therefore I can see where this signal is used, and I can directly jump from this motor back to the sequence. This is the cross-reference. You see, we have one point where the signal is generated. This is inside of the sequence, and we have the signal where this signal is used. Now I open the motor and will do this again. The signal is dragged. Now it is connected. Now I save this logic, and I would like to go back to our logic page where the sequence is generated. Because that's what I have to show to you, because this is the automatically generated cross-reference, which you can see over here. When we zoom into it, then you will see that the system really has the cross-reference into the right documentation, into the right function group, and this documentation and this cross-reference is automatically generated. Here is one part missing. This is based on the reason because the target sheet names, they have no long names. With these informations we can go to create a printout. We create a new object, and this new object is a documentation object. I create a name and I say OK to generate this new object. When this object is generated, we can open it with a double click. We have an empty cover sheet and an empty table of contents, and now I drag these documents by holding the left mouse key into this documentation object. So you see, all these three objects are dragged into this documentation object. Therefore I can take a look onto the generation of the context. You see, we have 7 pages inside of this documentation, and they are named, and we can print them to a PDF file. When this PDF file is printed, then you see this is the PDF output, and with this output we can take a look to our simple and startup documentation. You see, this is the sequence, there are the steps in it, and behind this we have the solenoid valve with a cross-reference in it, and we have the motor also with a cross-reference in it.